Hi, this is Jeff from the Ozark Mountains. That's in Missouri, in the USA. Now, some of you might recognize this as a Sharp PC-1500A. But you might be wondering what this little red box is. Well, that's the subject of this video. This is the new CE-158X. What is that? Well, let's find out. So what is the CE-158X? Well, it is a modern recreation of the Sharp CE-158, which is a serial and parallel interface for the Sharp PC-1500, 1500A, and Sharp PC-1600. We've incorporated all the same features in the 158X. We've got the serial port, the parallel port. We also have a second serial port which has a USB interface, and it plugs right into your PC-1500 just like the original. And it also has the ability to select between multiple ROM images. We'll talk more about that later. See there, we even have the name made as part of the case, and these little rubber strips just keep it at the correct height to plug it right into your computer. So before we get started using this thing, let's have a look inside, and then we'll go through the basic operation. Your CE-158X will come like this in a case in either red or black. I posted some photos of various case colors online, and these are two of the most favorite. Which is interesting because I only printed a red one because I had some red filament that I had for a while. I thought I might as well use that, and everybody really liked it. So there are 4 screws here, and these are a special screw for plastic. They have a coarse thread. They're designed not to split plastic. This is the circuit board. This is the dip switch where you can select the ROM image you wish to run. If you want to create your own ROM variations, you can do that. And in a later video, I'll go into more detail about the programming, but you would slide the switch to program. And for most EEPROM programmers, you would want to slide the switch over, which just disconnects power between the flash chip and the rest of the circuit. On some programmers like mine, they can't handle the parasitic load from the data lines. So you can jumper this pad right here and leave the switch on and use the USB cable as a power source. There are 4 screws/nuts, the standard ones that are used for about every DB25 connector. They are 1/4 inch on the outside, 440 thread. One other feature is this switch right here, which says input and print. This allows you to select between a printing only function for the parallel port like the original, or you can slide it to input, and you can also use it for data input, which is a new feature and that is incorporated into BASIC in the same way you would input data with the serial port. So once you get the 4 screws there and the 4 screw nut things out there, you kind of lift this back at an angle, kind of wiggle it just a bit, and you'll clear the DB25 connectors from the case. Now you notice this has an 18650 battery in here. These do not come with the 18650 battery. We chose this size because it is a pretty universal size the world over, and shipping it without the lithium battery makes shipping less expensive internationally and far less of a complication. And if you want to run this thing off a battery, you can find these, near where you live. You just need a 18650 cell that has a built-in protection circuit. And I'll put there in the user's manual, there's a link to a compatible cell so you can get the connector type and everything. But you see the connector polarity there. And to install the battery, you slip the wires through like that, slip it in, and then you'll want to fold the wires back over into this slot like so. Just tip that back down in at an angle. I find it's easier to have the power switch that direction when doing this. And there you go. There is a little piece of foam right here which just presses up on the battery and keeps it from rattling. Sometimes that foam can be a little difficult to get up around the corner there. But that's all there is to it. And just make sure when you're done, you're putting it back together, that you do not have this switch in program. And you want the switch on. Now I'll put this back together and then we'll see how it works. To connect your 158X to your PC-1500, you follow the same guidance that you would for the original 158. You want to make sure that both units are off. There is some embossing in the case here, which is going to be hard to see on the video. The manual outlines what each switch and connector and the LEDs are. So this is off. This is off. Carefully line that up. There is a polarizing notch there and some guides on the edge. Plug that in like so, and those little rubber strips I pointed out keep this at the right angle. Now, I turned to the CE-158X one since I have a battery in there, but you notice that the power LED, the on LED right over on this side, is not on. Just as in the original CE-158, this waits to get a power on signal from the computer before it turns everything fully on. Now you can see maybe just there we have a green power LED. Now the computer has found the CE-158. It sees the ROM that's in here, and it is ready to go. For the usage, I'm going to get you pointed down from up above. That'll be easier for me to type and you to see the screen and things like that. It looks like I've got an awful lot of wires and things here, and I do. I thought for this video I would show you the test setup I used when testing the 158Xs. So I've got the micro USB cable here, which is going to the USB port, which is the second serial port. I've got my primary serial port cable plugged in here, which is going to an FTDI USB to serial adapter. And this is an Arduino Uno, which is set up to simulate a printer and also work for the parallel input. So we'll be using that a little bit later. So now I'm just going to get zoomed in on the screen here so you can see what is happening. Okay, you'll notice on my screen capture I have 3 serial terminals open. The top left is the main serial port on the side. The bottom left is the second serial port, that's the USB cable, and the top right is the printer / parallel input simulator. So I've just powered everything up, and I can check that it is talking to the 158X by using one of the standard commands, like ComString, and it tells me we're set up for 300, 8, and 1. The original CE-158 could do a maximum of 2400 baud. But we can do a lot better than that, so I'm going to go set com space 19200. And if I do ComString again, we've got 19,200 baud. Now this is actually configured to do 38,400 baud maximum. That's more of an experimental thing. 19,200 is very stable. And I should point out at this point that 99% of the commands and how you use the 158X is just like you would use the original 158. We disassembled the original ROM and we modified it as little as possible to work with the new parts in the 158X. The next thing we need to do is do set dev, and this redirects some of the input-output functions to or from the CE-158X. So we want to do set dev ci, comma, co, And this will redirect the cassette input and cassette output functions to the serial port. There we go. And now we're going to do out stat 0. This sets the handshaking for, from the 158X. And you notice on the screen that the handshaking LEDs in the bottom right of the main serial port terminal there did change. Now on the second serial port, U1, U0 is the main serial port, U1 is the secondary port, the USB port. It does not use any handshaking signals, and it's permanently set to 19200. Okay, now we're ready to load something. So I'm going to load one of the test programs I used. I'm going to go cload with a small a, and that means load an ASCII file, and I'll hit enter. And then go connection, oops, syntext binary file, and I'm going to load this register test program. And you notice I didn't use a name here with an ASCII file. There is no name when you're doing a standard load over serial. And you'll also notice we see the busy indicator blinking. That is something that we added. So it gives you an indication that something is happening when you're trying to load a program, which the original did not do. The blinking is not consistent. It's not time-based. It's basically every time it sees an end-of-line character, it's changing the state of the busy annunciator. Okay. Oops. Always turn the lowercase off. Got rid of the small. We're in program mode, so I can do a list. And there is our program. I start out each of my test code with an error trap, so if something doesn't work right, I can see exactly where it goes wrong as it goes wrong. I'm going to go to run mode and do run. Okay, it's telling me it's just going to check all the setdev commands to make sure they are working right. And this is boring from the user perspective, but yes, they're working right. It was able to switch to the U1, the second serial port, and set to parallel input mode as well. And now it's setting with cassette in, cassette out, and backpack mode. Now it's testing various setcom variations to make sure those are all working right. That's fine. Outstat test is twiddling the handshaking bits. The handshaking on the 158 and the 158X is basically controlled by the user or the user's program. It is not active during sending and receiving files. That is a limitation of the device. And now we are going to print to over U0, the primary serial port, just some test messages. This is printing a header that you would get for a LPrint. And it's just telling you what you would get if you were viewing that in a hex viewer. Then it printed 456 after that without a carriage return. Now it has changed serial ports to U1. So yes, you can change serial ports programmatically. Of course, you can only use one at a time. This space test is just to the screen. It is L printing to the second serial port U1. Zone test is just a space test, and it's going to create an error here on purpose and trap it. So we have used both serial ports. We have input from the primary serial port and ASCII program. I'll go ahead and demonstrate the input-output functionality of the parallel port now. So I want to load a second program, another ASCII program. Oops. See if I can type this correctly this time. There we go. Okay. Connection. Syntext. LPT test. Okay, now I'm going to plug in the cable for the parallel port tester. The manual details all the handshaking signals for the parallel input, and I will point out that when Sharp released the CE-158, that they used pin 11 for the busy signal. The standard IBM convention for parallel ports is pin 10. So you'll need to make an adapter cable to drive a standard parallel printer. We kept the original pinout for compatibility's sake. Now I'm going to run this program, and the first thing it's going to do is a print number 9. There's a difference between an L print and a print number 9, which prints to directly to the parallel port no matter what other mode you're in. Print number 8 prints to the serial port. They use a slightly different mechanism to get to the same piece of code. So I'll press enter here, and it printed test 9 through the parallel port. Now we're going to do an L print type of test, which it came up. Yep, it did that right. And it input or output from the CE-158X to the computer, A through F, and now it's doing the same thing as a string array. One limitation to the way that the parallel input was implemented, used a lot of the same code that was already in there. So if you want to input a string, you have to input it as a string array. And numbers are limited to short integers, 8 bits, a single byte at a time. So that works. Let's say we want to load a binary program over the second serial port. How do we do that? If I look at the set dev settings now, oops, dev string, it is set to print to the or input from the parallel port and use the parallel port for input. So what we want to set that as is set dev U1. We want to use the secondary serial port, the USB interface. And then we want to do CI input, comma, CO. The set dev command, you can separate multiple items like this with a comma and set them all at once. It doesn't remember the last setting, so if you want to change it, you have to kind of start over again and build it up. So if I had this set to U0 before, for instance, if I just do set dev CI CO and do dev string, you notice it doesn't say U0. That's the default. Existing programs from back in the day wouldn't expect it to output a U0 there. And if I want to set U1 now like I did before, I have to type in the whole thing again. Set dev U1 CI CO. Okay, and I want to load, and I'm just doing a regular, C load, a program called Done. This one doesn't have an extension. Then the PC-1500 sends out a header at the beginning of the file, which incorporates the name of the file. So in a standard loading procedure like this, you want to make sure that your file name is the same as the embedded name so it doesn't get confusing. Hit enter there, and then from the second serial port, I'll say send text to binary file and all files, and there's done. And you notice busy is blinking much faster. Loading binary files is faster than loading ASCII files. There is a slightly different setup for the two on your terminal program. The ASCII file needs an end-of-line delay when it sees a carriage return. It needs to pause about 500 milliseconds because the PC-1500 is going to treat that input just like you typed it in, and it is going to parse it and tokenize it in. With a binary file, you need about 100 millisecond delay after the first 28 characters, which is that header, to give it time to process the header and reset the computer and things like that. With CoolTerm, you have to set up a packet delay, is what they call it. You can't set it to just work with the first 28 characters. So anyhow, we loaded that, and we can list it. It's Dungeon Quest. This is about an 8K game. So you can see how fast that loaded. We would be waiting a long time at 2400 baud. And if I wanted to save this, I could just do a C save, oops, done to, or something like that. And then I would set the terminal program I would do for CoolTerm here. I would say start a capture. Hit enter. And you can see it dumps pretty fast because you don't need that 100 millisecond packet delay. And I don't have that folder open up. But anyhow, now we just saved an 8K program in just a few seconds. That's pretty awesome. We added a new mode to the firmware on this called backpack mode that is designed to make it easy to use your PC-1500 with the backpack drive. In the near future, the Backpack Drive Plus will have a firmware update which incorporates these changes. So on the PC-1500 here, I would just do set dev backpack. And if I do a dev string, you can see it says CI/CO in backpack. The backpack mode acts like a macro. So when you enter it, it's automatically going to do, it'll automatically add the CI and CO modes. When you, if I can type, when you see load a program, it will automatically insert a header to tell the backpack what the program name is and if you're loading or saving. And then it'll wait for the backpack to be ready and send the data or receive the data, that type of thing. So it makes it fairly simple, and you don't have to remember to do all the set this and set that and set your COM and everything like that. You just put it in backpack mode and it works. And when we're releasing the new firmware for the backpack, I will show that in that video, because that'll make more sense to show how it works with that, about that product. I'm going to turn this off, I'm going to press the off button here. Then I'm going to slide the power switch on this CE-158X. And I just wanted to show you here. I'm going to go, now I can disconnect these two. That as I've had this plugged in, the charging light was on, and now it's saying the battery's full, and it has turned the full LED on. I've been testing with the F firmware setting here. This is detailed in the manual. There are 4 different firmware versions included. C and D have the minimum amount of changes needed to make it work. We were worried about compatibility with vintage programs, so we added those modes, those firmware versions, just in case that was necessary for some vintage programs. To change the firmware type, of course, you have everything off and disconnected like this, and you just rotate the switch. So F is kind of everything is enabled, and you'll be able to see in the manual what is what. And that's it. Works great. It's much faster than the original CE-158, which is nice. You can actually be able to get one, which is super nice, because these guys are getting very rare and very expensive. Now, the original small batch of these that we made have sold out already. We'll have some more. This is the end of March 2024. So in May sometime, we'll probably have some more of these ready. It just takes a while. There's a lot to building them and printing the cases and testing them and things like that. So I will put a link to the product page for these in the video description. If you have any questions, let me know in the comment section down there. I'd love to hear from you. And we have another new product coming out. Well, that video will be out shortly. Thanks, and bye.